About 2 years ago, I picked up these. These are filament LEDs, or LED filaments, I'm not quite sure. Essentially, it is a silicon flexible, kind of a PCB, I guess. I don't know how they're constructed, but inside this are loads and loads of little LEDs. Yeah, there we go, you can see them there. So lots of little LEDs in here. I don't know how they make it so flexible, but 2 years ago, I was hoping to do a project with these, and it was going to be to convert this thing that I've got. Currently, it is home to my beautiful paper plant, and it's essentially like a precision weighing instrument. So it has a door on the front that you can lift up, and then you put your things inside and weigh them without any kind of environmental factors being an issue. And I'm hoping to put these LED filaments all in strips along inside it. So when it's off, you won't really see them. And when it's on, you'll see this. These are the filaments lit. So I'm feeding them 3 volts and they're currently drawing 127 milliamps. We'll get a better idea if we only run one, because they're all currently feeding off what is essentially a one resistor, because they're sharing the same power supply cable. So let's just get rid of that. So this beautiful pink one is currently drawing 73 milliamps. So it doesn't really work when they're all pinned together. So now it's 100 milliamps. But if I take the pink one away, 84 milliamps. So it is about them sharing these cables. Plus, recently, I was looking at some of these cables, some of these croc clips, and like the resistance is really high. So they're like poorly constructed on the inside, I think. It's just where it's just not making good contact in there. Anyway, that's by the by. Look at the glow that puts out. Now, interestingly, when we looked at the LEDs before, we could see the individual, all the individual LEDs in there. I wonder if we can focus on that and change the camera a little bit so you can see it. Yeah, I think you can see it there. You can still see them if I just turn it round. So it has fairly even illumination, and even when the LEDs are faced away, it's still fairly nicely illuminated. Clearly not as bright as the front. Now we've got to figure out a way to drive these. Now we could just whack a resistor on. With 5 volts, 27 ohms would be fine. But I want to do it in a bit more of a cool way. It'd be nice to be able to vary the brightness of these, ideally by touch, but we're going to explore some options. So I'm going to go away and find a microcontroller. So super simple example here with an Arduino Nano. Using the analog right, we can vary the brightness of an LED, and it basically is PWM, except for some limited number of steps. But you'll see here, if I use this little touch IC, I can signal the Arduino to change the brightness of that LED, which is good, but we can do better than that. We can go smaller than that. So this is an ATtiny 85 doing exactly the same thing that the Nano did. So we can really shrink these projects. But in doing this with this lovely 8-pin IC, it did remind me of something. So about 10 years ago, 2015, about 10 years, yeah, I suppose it is about 10 years ago, I did a project where I was looking at PWM. So I was learning about the 555 timer for the first time, and I got this book out of the library. I still don't really know all of the ins and outs of the 555 timer, but I was looking at it as a way of PWMing stuff. And I watched the video again, and there's a diagram in there. So let me grab the diagram. So here we are, 555 PWM. I've got a screenshot of the actual diagram. I think my one's better these days. But it's from a book called IC555 Projects by E.A. Parr. And it was really, really useful in helping me understand the circuit. not necessarily understanding exactly how the innards of a 555 work. I think it's like 3 comparators or something. You'll see I started drawing the diagram and sort of ran out of space. So I drew another one here and still made a mistake. But here's our 555. So we're set up with 2 resistors here. One of them's a variable resistor. We've got our capacitor down here, which is a timing capacitor, and then a diode over here. And that diode is bypassing our second resistor. And that's the one that's controlling the timing, the trigger. So as this capacitor fills up, so it's only this one that's controlling that. And what that means, without going into all the weird calculations, because I can't do the maths, but essentially it means this resistor controls the duty cycle, not the frequency. So we can change this and the frequency is going to change, but the duty cycle will change with this. So this frequency won't stay the same, but we can modify the duty cycle. There is another version of this circuit which has a diode going the other way, which does keep a constant frequency, but I don't need that. PWM isn't that complex. As long as the frequency is high enough, I think it's probably okay. So I'm going to build this up and we'll see it working. I'll get the scope going as well. I don't have a variable resistor, but I do have a potentiometer, which you can use as a variable resistor. You just only need 2 of the legs. So we will take one of these and pop it into our board. Just there. And the other one is going to go to power. So I'll just take the wiper and put that into power there. So now I've got my variable resistor hooked up and I just need to pop ground in over here. So you don't see anything happening right now, but there we go. So if I change this, I can make it go really low. You don't want to go all the way to the bottom. And the reason you don't want to do that is because you start sinking a ton of current into the 555. Look at that, that's cool. Just dim those down a bit and then we'll bring the scope probe in, I think. Right, the scope is good to go. Let's get our probe hooked up to the output pin. Just there. And I haven't got any grounds handy, so I'll just use the leg of this LED and hook on. Okay, well, we're already getting a signal. Let's expand horizontally and see what it says. So it looks like the duty cycle there in the bottom left-hand corner, it says 28%. So that's the positive duty cycle. So that's how long it's on for. And then I can just expand that using the potentiometer as I turn it. So we're now at 51, 52, 56. Let's see. Right, with this potentiometer, because it only goes up to 10K, the most we can get is 61%. And then if I turn it right down, it'll basically just go off. Yeah, so we won't go all the way to the bottom. There you go, 0.18. And just need to nudge it up a little bit. There we go, 1% on. So they're very, very dim. There we go. Little bit more, 5%, and they're visibly bright. Visibly. So that's our circuit. You'll notice there's actually there's a MOSFET in here as well. This is the FQP6NL, 60NL, something like that. Anyway, I'm using that to drive this. These resistors here are 27 ohms, so they're limiting the current through these to be around 70 milliamps at 5 volts. But we can do better than this. Well, I hope we can. I don't want to use this. This is rubbish. I don't want there to be a dial. I want it to be touch, just like this one here. But how do we do that? How are we going to swap out that resistor in circuit using touch? Well, thankfully, CMOS 4000 series to the rescue. there are options. So let's just get this out of the way for a second. In fact, I'll just unplug the power. Oh boy, I've missed using 4000 series ICs. So this is a circuit that I've drawn up which should swap our resistors in and out. I've started off with a CD4510. So this is a up-down counter, has these Q outputs. And those Q outputs are actually binary coded decimal. Now, you'll realize why I've chosen that in a second, because the other one that's on here is this 4051. That is an analog multiplexer or demultiplexer. So you can have lots of inputs and one common output, or you can have one common input and lots of different outputs. So right here, we've got Q1, Q2, and C we're not using. But essentially, these are inputs for telling it which output to choose or which input to send to common. So by using a combination of this, so this takes the clock input, and then the Q outputs changing the inputs on the 4051. And then depending on which input is selected, 5 volts goes through one of the resistors here, and then makes its way out to the common output, which goes to the 555. So let's have a little look at this circuit. Back in with our 555 and out with the potentiometer. We don't need that. Let's get power going onto this. Right, so we've got that working. And then we can bring in this board. So this is my new board. It's got the 4051 CD4510 and the 4051 over here. So let's just power these up. I'm using double blue cables for power and ground, which is great. I should have just picked up another one. And then we need to take the signal from here, which I believe is pin 4. Actually, I don't need to believe. I can look at my diagram. No, it's not. It's pin 3. So pin 3. And then I'm going to replace the resistor. There we go. And as I step through, you'll see the duty cycle changing on the display. And in fact, I can change the time base a little bit there. So you can see we're at about 10% duty cycle. There's 17%, 64%, and then the time base is wrong to show that. Let's see. What is it? About 90? 99. So when it's at 99, it's running through a 1 meg resistor on over here. So these are input resistors. So we've got 470, 1 meg there. This one's a 10K, and that one looks like it's a 1K. And we can just step through. Now, I really like the resistor ratios here. I think it's very pleasing to the eye. Interestingly enough, these kind of really display it quite well, but brightness isn't linear. So your eyes have like kind of a logarithmic response to brightness. So really, it's just about playing with the resistor values. I did see this curve online, but don't really know how to translate that to this. So just playing with some different resistor values, and you can see how quickly it changes in that scope. That is fantastic. I love how fast it is that you can just quickly switch it out like that instead of that boring, annoying potentiometer. These switches, interestingly, they're very sensitive. You can see the little red light when it goes, but I don't even have to touch it. It's so cool. But in making this, I did realize that, I mean, there's a lot going on here, but maybe it's not really necessary. So what are we doing in this circuit? Essentially, we're taking this resistor out of circuit and replacing it with something else. But the only reason this needs to be here is to access 5 volts. So really, we just need a resistor with 5 volts on one end going into this section of the circuit. So we don't need an analog multiplexer. We don't really need anything like that. We can use something else. And here is that something else. So this is a very similar kind of circuit. It does basically the same thing, but uses a single IC instead. But due to the nature of the IC that we're using, it does require some diodes. But as you can see, I can change that duty cycle just as easily with this circuit as I could the last one, which used 2 ICs. So what is this IC? Well, let's just move all this out of the way for a sec. This new one is actually done with a CD4017. This is a Johnson counter. Essentially, you take a clock in and the output changes. So clock Q1 or Q0 goes high, clock Q1 goes high, clock Q2 goes high. But because that high signal is just 5 volts, we're just sending 5 volts through, ish. It's not really 5 volts. I've had to put a diode in because when these outputs are selected, they go high, but when they're not selected, they go low. So you start stealing power from the circuit, which, you know, doesn't really matter that much when it's a 1K. Well, no, actually, it's the other way around. It doesn't matter that much when it's a 1 meg, but when it's a 1K, it does start mattering. You're pulling too much out. So you have to put diodes in line so that you're steering that current through. And down here on Q3, I'm just resetting so it goes back to 0. Now, the interesting thing about this is that I think is it a 14 stage? I've just looked it up. I knew it was a decade counter. I don't know why I didn't think that was 10. It's 10 outputs. So I could wire up all 10 outputs to have 10 different levels of brightness. I don't need that. I think having only a few is fine. But this uses just the one IC. Well, actually 2, isn't it? 2 and a 5. This one and the 555. So I think that's the approach I'm going for. I'm going to need to make up a PCB because I'd look around and I can't find any Vera boards. So I'm going to have to buy some more. But it might be nice to make a PCB. So right now, I'm looking at making a guitar pedal. I've never made one of those before, but I've picked up all of the bits I think I might need. Some potentiometers. What else have we got? Oh, this big, amazing, clunky switch. Don't even know if I need that. And these ICs are in here somewhere. Oh, here we go. So it's going to be a delay pedal with the PT2399. I found a few circuits online that look good for that. And even the datasheet has a really simple one. So it might be nice to design a PCB so I can get used to it before I attempt that project. So we've gone from the 555 to the 4510 and the 4051 circuit, all the way over to the 4017 plus diodes. But not forgetting, we also did some Arduino stuff, but we're not going to use them. So this is the scale. It's apparently used by chemists. So this is fairly old, but I did a little digging to find out, just to make sure it wasn't really precious. But it's by a company called W&J, George and Becker. Now, they were founded in 1897, but this one isn't from then. They didn't start using that name. They were a merger of two companies. They didn't start using that name until the 1950s. And according to the British Science Museum, they stopped trading in 1954 with a merger with another company. So this ranges from 1950 to 1954, so not too old. And I had a look at some auctions of these things. They don't go for a lot, like 16 to 30 pounds. I guess people don't really have a use for them. But what are we going to do with it? Well, I thought we'd have a little look about where we're going to mount these LEDs. We could have a little look as well. I realised there's a little dial down here. I didn't know that did anything. But hopefully you can see through the glass. If I turn that, it raises the thing on the inside. Just looking at the screen to see if you can see it. I assume that's when you start your measurement, is when you do that. It's got these sort of glass triangles, which it's balancing on. Fascinating thing. But if I raise that all the way to the top, I can actually lift this all the way out. I won't do that right now because there's like string here, a pulley system. But what I want to do is pop these LEDs along the front here. It's very hard for me to demonstrate, but I'll put 6 in. And I've got this leftover wire from when I had my rewire done in the house. So these are like solid core copper wires. It's pretty rigid, and I'm hoping I can strip this insulation and then run a bus bar along the top and a bus bar along the bottom. And that's where I'll connect these with a single resistor, which I'll probably put at the top, because when this is closed, it'll be largely hidden, I think. I'm not sure. We'll figure that out at some point. But why don't I cue a terrible 3D mock-up? Yeah, I think you'll agree that's sufficiently terrible. Now, I'm not sure how I'm connecting those bus bars yet, but the PCBs have arrived. Well, they're here. So these are the PCBs. I bought 5 of them. These came from JLCPCB. Now, you could just use whoever you like, whoever's cheapest, but these were pretty cheap. They're $5 for these boards, and that's delivered. It uses their global direct shipping. And I got them in 10 days. So ordered them on a Sunday and they arrived at my door 10 days later, which just is incredible. When I saw that it'd been on a plane, I just thought, how have you done that for $5? And it wasn't necessarily a small package either. It was like a lot bigger than it needed to be. Still, can't fault it for $5. But again, there are loads out there. Dirty PCBs, you've got Osh Park with the purple PCBs, you've got PCB Way, all of those places. So just pick whatever works for you. I had a few issues, not gonna lie. Basically forgot how to use the software. So I had like 2 hours of playing around before I did the screen recording of just trying to remember the basics. And I floundered a bit. And luckily I've got my Discord crew who I went to and just basically said I'd forgotten all the shortcuts and stuff. And while they didn't like give me a tutorial or anything, they did just chatting with them made it all flood back really. So I appreciated that. So now we can just build some, I think. Hopefully I've got all the right components. I did, after ordering this, think, have I got any 0805? I've got so many 0603, but I built it with 0805. And thankfully, I've got some. So let's build it. I'm going to start out with the 10K resistors because I think I know where most of them go. That's a lot of the resistors. Hopefully I remember how to do this. So all I'm going to do is put a blob of solder on one pad, and then I'm going to slide the component on. I think R7 is a 10K. It could stand to be higher than that, I think. R5 is 10K. I've got a bit too much solder on that one. What else is 10K? I think one of these is 10K. I'll have to look back at my diagram just to check, because that's the timing one. I did wonder why these resistors were out of order, but they are out of order for a reason. So this is 0.1, 0.2, 0.3, 0.4. So when you tap it, that's the order in which they go. Have we done all of the Yeah, I think we've done all of our 10K. Let's just try and take a little bit of solder off R6 there. That's better. Ish. 2, 3. Okay. Do I remember how to do this? Not at all. Well, that one's gone on well. Forgotten the pain of this. Let's just turn this board around. Oh, don't you do that. There we go. There we go. They're not so difficult, are they? Yeah, I've not forgotten how to do it. Yeah, they look okay. Right. Let's throw on our capacitors next. Now we need 100 nanofarad capacitors. There's only one capacitor surface mount on here that isn't 100 nanofarad. And that is this one here, C7. Because C7 is part of our touch circuit. Actually, C3, it could be 100 nanofarad, it doesn't really matter. But I might see if I've got a different one, like a 10 microfarad, I probably do. So 1, 2, 3, 4. Ah, that's it. I've pulled too many out, but that's okay. Oh, it's up there. Bit too much solder on that one, but that's just going to make it more conductive, right? There we go. I've got some 10 microfarad 0805s here, so we'll do one of these. chunky boy. Then we've got a 22 picofarad capacitor, which is going up here for the touch input. I think it was picofarad. I haven't checked. Gosh, I forgot how it makes my hands shake when I'm like trying to be really careful. Now we've got to get all the surface mount ones done. So we've got a resistor there, which I think is going to be, I think I had it in my schematic as 100 ohms. In fact, I think it could be 0 ohms. I don't think it really is necessary. I shouldn't have put it in there. It's a logic level transistor, so that's 150 ohms that I've just put in here. This one's going to the base. Now, what else is surface mount that's left? My ICs. Okay, so I've got the 555 to hand. This should be a TS555. Not that it matters in this case. I think a TS one is like the CMOS version, which means it can use lower power, but in this case, I'm not worried about that. So we're just going to do pin 1. And I might just dab a little flux in here, because I might try drag soldering it. All right. Pin 1 at the top. There we go. Just do another one there. It should really come at you from the other side, but that is done. That's done. That's done. They're not the prettiest, but you'll do. The chip is slightly skew-if there, but it could do with coming this way a little, but I think that's fine. Then we need a CD4017, which I have a ton of because I used them in, gosh, I don't remember now. My crack badge, maybe? Actually, we don't need to open a new pack. There's some just here. That could do with going forward. It's weird sitting this far back because I've got the camera in my way, so I can't, oops, I can't see. That's good enough. I don't care now. Sorted. Well, I say that, I've missed the second pin there. And that is an important pin. I will just have a little check. Yeah, it looks good to me. Now we need those touch ICs. Where are they? Where are they actually? Found them. They were hiding. Right, these are too small for me to read what's on them, so hopefully these are the right ones. So I think they have a line on them. See if it's possible to focus on that. I don't think it is. I haven't got a clue what you can see there, but there should be a line. And I think that goes to pin 1, I hope. I could do with a slightly smaller tip for my iron for this. So they are very tiny, tiny legs. You're a little skew. Let's just a tiny adjustment. That'll do. It could do with going this way a little bit more, but whatever. Might just give that, just because I can't really get my iron onto that super well. I'm just gonna give all of these a little touch. What I should have done is chosen a footprint that was a little bit more friendly. And by footprint, I just mean giving myself longer legs to solder onto would have been helpful. All right, that looks done to me. Definitely needed to go over further, but that's fine. We're getting there now. So what else is surface mount? Just these resistors. Now in my diagram, I have only put 3, so we're gonna have to make up another one. So I think we do 470, 1K, 10K, 1 meg. I can't remember what we were looking at when we did it before. Maybe I could put 15K in there and that could still be 470. 470, 10, 20K. Let's go with 20K. What have we got? I've got 18. That'll do. So we want 470. 470. That goes to R1. So 470 is going to R1. I think I probably want to do it this way around. Give myself a bit more space. Now I've got the IC in there. Maybe I should have put the IC in second. Oh, we need another 10K, don't we? Now we can get those diodes in. I did find some MELF, I think that's what they are. I hope so, otherwise that sounds weird. Some MELF diodes in my drawer. So I wish before I'd made this, I did double check that I didn't have anything that was surface mount, which would have been nicer, I think, than these. But I kind of like the old school style glass body diodes, but the MELF ones are glass body, so they would have been just as good. And they would have had that kind of cool look about them. When I was designing this PCB, there was a point when I was doing it where one of these diodes was around the other way, which I realized when I was doing it, that's going to be a pain because I might forget. I know that there's silkscreen on here to tell me, but you never know. And it just wouldn't have worked. And I would have been scratching my head. It looks kind of nice now. Like I'm kind of into it. Oh, I love it. I've tidied up some of the soldering and I've also soldered in some power wires and a lead onto the sense pin. I did have to change one of these diodes because I think I'd got my models mixed up. So whack this into diode test mode. I'll just put it across one of these. You'll see the voltage drop there. The forward voltage is what, 0.3 volts. And this one that I took out has a forward voltage drop of 0.6. So I was using these diodes here. They're the 1SS86. Now I can't remember why I bought these, but turns out they're just Schottky diodes, but the low forward voltage drop is preferable, and I just had some other ones in this box and I just pulled something out, so I put the wrong one in, but not the end of the world. So I've been through and just double checked all of my connections. Everything looks good, so we're about ready for a bit of a test. Right, power supply's on, so let's get our scope hooked up. So we've got a ground pad there, hopefully that's going to be sufficient. And then we've got the PWM test point just here. Whoa, what is going on? is wild. Oh, interesting. The ground wasn't connected properly, so it was getting a weird result. So what are we looking at here? So we've got, what, 55% duty cycle there? Let's see if this works. Hey, okay. So then we get to 68. Then it doesn't know because the horizontal needs to change. 99.1, brilliant. And then back to the lowest brightness at, oh, it is jumping around. There we go, give it a bit less of a view there, and it's giving us 10%. So we go 10%, 50%, roughly 70, 10, I missed out a step. There we go. Hey, look at that. I'm pleased. Right, I guess it's time to start building this thing, but it's dark, so I'm going to do this tomorrow. Yeah, that looks all right. Happy with that. Let's just get rid of that. So it looks like we're basically done, I think. It's all enclosed in my little box. You'll have watched a little time lapse, I'm sure. At the top, we've got a little sensor coil, which is allowing us to use the little touch sensor, the TP223, if I can tap it right. I'll show you some close-ups. They're a little wobbly. I think I needed stronger bus bars. You can see it moves around quite a lot. And I measured my spacing wrong, so I ended up having to put an extra one in. But I kind of love it. It's brilliant. I've drilled through the case a little. What can you do? I needed to get the USB cable around, and instead of bringing the bus bars all the way down, I decided to cut them short because I figured this bare copper would probably interact with the other bare copper bus bar by accident at some point. But that is pretty good. I've used brass plated screw eyes, are they called? I'm not sure, to help route some of the cables in the case. I figured the brass would sort of go along with the other brass and wouldn't stand out too much. Then again, I've got a big black circuit board in there that doesn't look right. But the little platters for the weighing scales are also black. So in terms of the theme, the things that stand out most of all are the neon bloody LEDs. Overall, I'm pretty happy. It's not a bad job. It's not a great job, but it could all be undone if necessary, if I needed to.